Hi guys, so this one will be pretty quick and easy. We're going to take a look at how to find the y-intercept, and there's just a really quick method for doing that. So let's take a look. So surprise, surprise, we are now going to talk about y-intercepts for quadratic functions, right? This should be no big shock for anybody. We have talked about y-intercepts for basically since day one of this class, right? For every sort of function that we've done. When we did linear functions, we saw y equals mx plus b, right? B represented the output for our y-intercept, right? And when we talked about exponentials, we saw that the a value, so y equals a times b to the x, right? The a was our initial value, which was our, of course, y-intercept. So y-intercepts are incredibly important, right? They represent our initial value for our function. They're very, very important. They give us a lot of great information. So of course we're going to talk about y-intercepts with our quadratic functions. So let's talk about how we find our y-intercept, okay? Well, we know that the y-intercept is, of course, the point at which our function crosses the y-axis. That should come as no big surprise. I don't know why I drew that arrow there, right? The point that our graph is going to sort of cross this y-axis, and I'm going to have to extend this up to sort of think about where this graph is going to hit it, okay? So it would be this point, right, where our graph sort of intercepts our y-axis there, okay? How do we find it when we're dealing with a quadratic function? So the y-intercept of any parabola is the point 0c, okay? So any parabola of the form, right, f of x equals ax squared plus bx plus c, well, our y-intercept is simply the point 0c. So whatever your c value is, whatever that coefficient is, okay, that's what your y value will be. That's where your graph is going to hit the y-axis at that point. All right, and that should make sense because remember, when we're looking for an intercept, right, we plug in 0 for the opposite. So if we're looking for the y-intercept, we're of course plugging in 0 for x, okay? And if we have the function ax squared plus bx plus c, and we plug in 0 for x, that means a times 0 squared plus b times 0. I'm just plugging in 0 everywhere I see x plus c. Well, 0 squared is 0, and a times 0 is going to be 0, so that's going to go away. B times 0 is going to be 0, that's going to go away, and you're just left with c, okay? So the y-intercept is 0c, okay? Which is going to make it really easy, you guys. This is why I keep saying, always find your a, b, and c coefficients first. It's going to give you so much information, right? The second we find c, we've also found the y coordinate for our y-intercept, all right? We've basically found our y-intercept. So again, if we look at this same example that we've been looking at since the beginning, y equals x squared minus 10x plus 19, well, c equals 19, you guys. So the y-intercept is 0c, which means it's 0, 19. All right, that should make a lot of sense. And again, here's some proof if you don't quite believe me yet. All right, again, if I'm looking for the y-intercept, I'm plugging in 0 for x. So everywhere I see an x, I'm going to plug in 0. So that means f of 0 is going to be 0 squared minus 10 times 0 plus 19. Well, 0 squared is 0, so that's going to go away. 10 times 0 is 0, so that's going to go away, which just leaves us with 19. All right, so our y-intercept is 0, 19. All right, and that should make sense for this graph. This point up here is going to be 0. We're going to be up on 19, all right? That's where this particular parabola is going to hit the y-axis. It's going to intercept the y-axis, okay? So it's really nice. It's not too bad to find a y-intercept for a quadratic function because it's literally just this c value, right? It's a 0, and that c value gives you the ordered pair that you need right off the bat.